What's up, everyone, and welcome to episode 3 of the Sorta No Science podcast. I'm Drew, and thank you for listening. So today, we're just going to talk about some physics, and then talk about a new figure of physics, Galileo. So, let's get to it. The first article that I'm going to talk about today is from phys.org. It's called "The Wolfram Physics Project Hopes to Find Fundamental Theory of Physics." So physicist Stephen Wolfram, the creator of Mathematica and Wolfram Alpha, has announced the Wolfram Project. Pretty much, it just hopes to have people from around the world help and find a fundamental theory of physics. So what a fundamental theory is, or what they're trying to find, is pretty much a theory that ties all of physics together. It's what Albert Einstein was actually working on in the more of the late stages of his life before he passed away. But he suggests that the universe can be modeled by points in space, and certain rules can be applied to then create more points, and then the points can be put together to build a network. And the rules that would be applied would eventually determine the characteristics of a galaxy. Or, my bad, not a galaxy, a universe. He says that the only thing that's needed right now is to come up with the rules. So this is where the project comes in. And I think it's very cool because literally anyone could participate. So you could go to his website, or I think it's a website dedicated strictly to the Wolfram Physics Project, but you can participate and you can find more information on it. And if you really wanted to, you could create a rule and put it in there. All right, the second thing we're going to talk about today is also from phys.org. Satellite galaxies of the Milky Way help test dark matter theory. So a research team from the University of California, Riverside report that satellite galaxies can be used to test properties of dark matter. So they created a theory called SDIM, self-interacting dark matter. And what they hope that this theory will do will explain the diverse dark matter distributions in galaxies. And specifically right now, what they're looking at is satellite galaxies. So galaxies that are in orbit pretty much around another galaxy. So the prevailing theory right now is the cold dark matter theory, and that explains the universe and how structures emerge from it, but it doesn't explain the distribution of dark matter in these structures, especially in galaxies. So they studied the SDIM evolution in subhalos, which are dark matter clumps, which are hosts for satellite galaxies. And they found that the interaction between the subhalos and the Milky Way's gravitational tides leads to very diverse distributions in the inner parts of these subhalos. And in this theory, the SDIM, dark matter is predicted to self-interact through this new dark force, which they didn't explain anything in terms of what I've read, but I'm probably going to look into that a little bit more to see if they have like any sort of news about it or anything. And particles are assumed to collide very strongly in these inner clumps at the center of these satellite galaxies that they're studying. And the team stresses that their work mainly focuses on this self-interacting dark matter and doesn't make an assessment that cold dark matter explains the satellite galaxies, their creation, and the dark matter in any way. But they plan to extend their study to go on to even more satellite galaxies. All right, so that's kind of going to wrap up the kind of like news that I'm going to talk about today. The last thing we're going to talk about today is the new figure of physics. This week, it's Galileo Galilei. So he was born in 1564 and he died in 1642. And so I'm just gonna kind of just give a brief overview of some of the things that he's more well known for. And if you find any of it intriguing, please look some stuff up. Maybe you'll be very interested. So he made a more powerful telescope. He wasn't. A lot of people think that he's the one who invented the telescope, but he's not. But the things that he did with his own, he did a lot of experimentation of making his own lenses and such, and he was actually able to make a lot more powerful one, have a lot more magnification to be able to see more. And with that, he discovered some of the moons of Jupiter, and he also discovered that the moon wasn't smooth like everyone thought, and it actually had craters. And then with that, he also discovered the phases of Venus. So just like the moon has phases, crescents and gibbous and so forth, Venus goes through the same thing. He also created the first pendulum clock. And to me, what I think the most interesting fact about him that I found when I was looking this stuff up was that he was actually a college dropout. And originally, he wanted to be a monk, but the family that he was in was stated that they were a little more noble, and his father really didn't want him doing that. He wanted him to go to school, and he wanted him to study medicine. So he went to school, and he started studying medicine, and then he found he was very interested in mathematics and kind of astronomy and stuff. So he kind of leaned more towards that stuff, and then eventually he didn't go to school. He was a dropout. And another thing was that he spent the final years of his life under house arrest because of the church. So he supported the heliocentric theory, which was the theory that the sun, that everything revolved around the sun instead of what the church originally said, that everything revolved around the earth. And another really weird thing that I found from this was that the church didn't say he was right until 1992. So that's only like 28 years ago, which isn't that long when he was doing this in the 1600s. Like 400 years ago. And then he's also stated to be the father of observational astronomy. And one thing that I was told, actually in the astronomy class that I'm in now, was that he also did a lot of work. He did a lot of work trying to map out sunspots. So he spent a lot of time looking through his telescope at the sun, which at that point in time that they didn't have sun filters like they do now. So one thing you should never do is look at the sun through your telescope without a filter. But they didn't have that technology then, so he just looked at it anyway. And in his later life, he went blind. So a lot of people just associate that with looking at the sun too much. And that's what I was told, even, was that he went blind from looking at the sun. But in reality, he actually went blind from complications with cataracts and glaucoma. But yeah, that kind of wraps it up for today. This week's is a tad shorter, and I got to get on a better schedule of kind of being more consistent on what days I want to upload this stuff and whatnot. But yeah, thank you for listening. If you haven't listened to episode 1 or episode 2, please do. The stuff I talk about in those is still very relevant. So maybe you'll find something interesting. And other than that, thank you for listening. Peace.